Okay, you are with me on this one again. You are with me on this one. This is Mass 209. We are treating the Newton forward interpolation. The Newton forward interpolation. Now the question is, y is equal to the exponent of 2x for x. Again, y is equal to the exponent of 2x for x. It says evaluate 0.05 using the table. Now look at it, 0.05. Now the table itself is starting from 0.00, 0.10, 0.20, 0.30, 0.40. But because we are looking for 0.05, that is why we are using Newton forward interpolation. Why? Because the Newton forward interpolation is used for evaluating figures that is close to the beginning of a table. You see, 0.05 will fall between this category, the category of within 0.00 and 0.10, between this edge here, this category. That is why we are using Newton forward interpolation. But if we're looking for example, 0.35, this region. If you're looking for this region, for example, let's assume that it was 0.35 that was here. What will be happening is that you'll be using what? Newton backward interpolation. Why? Because Newton backward interpolation is used to evaluate figures near the ending of a table. So NFI, Newton forward for beginning of the table, Newton backward for what? Ending of the table, near the ending of the table. Let's not forget that. Okay, so as we have earlier stated, let's get into the business. We have 0.00, we have 0.30, and we have it like this. So what do we do from here? This one is 0.10. Now you can discover also from the table that these things are operating at equal interval. What's the difference between 0.00 and 0.10? 10. What's the difference between this and this? 10. This and this? 10. This and this? 10. So we are saying that NFI, Newton forward interpolation, and Newton backward interpolation, they all operate at what we call equal intervals. Equal interval. That means the difference between their x values must be equal. 10, 10, 10, 20, 20, 20, 30, 30, 30, 40, however the case may be. It must be what? Equal intervals. Okay. Having said all of these things, then we begin to do what? We begin to construct the difference table. So let's construct the difference. So step one is to construct the difference table. That's the first step. You have to construct the difference table. And how do we construct this difference table? You say x should be here. You say y should be here. You say the forward difference of y should be here. The forward difference squared of y. So what will we be writing in these x values? We will be writing all the values we see in x according to the question. Don't forget, from here to here is the question. Do you understand? Is the question. So let's go. We have 0.00, we have 0.10, we have 0.20, we have 0.30, we have 0.40. Right? Now in the y part we have 1 point. I'm just simply stating out what is in this table. 1.00, 1.2214, 1.4918, 1.8221, 2.255. Now what about the change in y? The change in y now is, we are simply saying, remember from the shift operator, I said the forward difference of y naught is what? Y1 minus y naught. I said the forward difference of y1 is y2 minus y1. What we are simply doing, where we are going to minus where we are coming from. Where we are going to minus where we are coming from. Is that okay? So having said all of these things, we now begin to find out that how do we fill up this table? How do we fill this up? He said this minus this. So 1.2214, where we are going to, this is where we are going to, this is where we are coming from. 1.2214 minus 1 is 0.2214. Again, this is where we are going to, this is where we are coming from. So this place will be 0.2704. This minus this is 0.3303. This minus this is 0.4034. Did you see that? So we are saying where we are going to minus where we are coming from. Where we are going to minus where we are coming from. Of course, mathematics is simple. So how do we proceed from here? Again, where we are going to minus where we are coming from, that will be 0.0490. Yes, that will be 0.0599. That will be 0.0731. Did you see that? That's the forward difference to the power of 2 of y. This minus this is this. This minus this is this. This minus this is this. Change squared y. Now the next thing we are supposed to do from here is to tolerate the forward difference cubed to the power, power of 3. So this minus this will give you 0.0109. 0.0109, 0.00731. 4 to the power of 4 of y is 0.0023. Okay, so now that we have been able to construct the difference table, the next step is to do a step 2. Step 2. Now we are listing out the parameters. We have x naught, the first value of x, which is 0.00. We have y naught, the first value of y, which is 1.00. We have h. We have h, the interval of differencing. So h is 10, right? 10. Good. And then we have u, which is x minus x naught divided by h. Now what are we looking for? X there, x is what we are looking for, which is 0.05. 0.05, because they said evaluate 0.05, minus x naught is 0.00. Let us divide it by h, which is the interval of differencing. The interval of differencing is 10, as you can see that, or 0.1. 0.10 minus 0.00 is 0.10. So h is 0.10. 0.10. So our u will be 0.5. 0.5. U there is 0.5. Having said all of these things, then we begin to find out what. Now, there is something I want to put across to you. This calculation is a little bit wild. 0.0132. Did you see that? 0.0132. Now, having said all of these things, we begin to find out what our step 2 will be. What our step 2 will be. And so we said, step 2, clean this part. Step 2 will be to what? To introduce the formula. Step 2. We have to do what? We have to introduce the formula. I haven't stated out your parameters. Let's introduce the formula. The formula says that f of x is equal to y naught plus u, change in y naught, over 1 factorial, plus u minus 1, change squared y naught, over 2 factorial, plus u minus 1, u minus 2, change cubed y naught, over 3 factorial, as we approach infinity. As we approach what? Infinity. Now, as we have said this, then we begin to slot in the values. Now, from the table I just cleaned the table. Now, from the table I just cleaned, you discover that y naught is so let's impute the value. So f of 0.05. Remember, we're looking for 0.05 from the table I cleaned. You remember, we are evaluating from the question. We are evaluating 0.05, right? Good. So what do? F of 0.05 will be 1.00, which is y naught. Y naught was 1.00, right? Plus we have 0.5 into bracket 0.2214. Did you see that? 0.2214 plus 0.5 into the bracket minus 0.5. We are filling in the gap. Now u is what we just found here, 0.5, right? U is what you just found here, 0.5. So you are taking it into the formula, 0.5. What is the change in y naught? The change in y naught, as you can see it from the table there, is 0.2214. I drew a table, right? So the first values in those tables, I drew a table like this. And I put x here, I put y here, I put a change in y, and I put a change squared of y. So the first values, you understand? Because we are doing a Newton forward interpolation. Is that correct? So we are simply saying that y naught, which is 1.0 plus u 0.5, change in y naught. The change in y naught, if you look at the categories of the y's, the first value there is 0.2214 divided by 1 factorial. You have it here, plus u 0.5. Now, how did I get this minus 0.5? When we say 0.5 is half. So 0.5 minus 1 is minus 0.5. And then you multiply it by change squared of y naught. And what is change squared of y naught? What do you think change squared of y naught will be? Or change to the power of 2 of y naught will be 0.0490. Is that correct? Divided by 2. Because 2 factorial means 2 times 1, plus, right? Now we go to plus u again is 0.5 into bracket u minus 1 minus 0.5 into the bracket u minus 2 minus 1.5. Then change cubed. What is change to the power of 3? It's in the book there. It's in the table there. 0.0109 0.0109 divided by 6. Now that we have that, then we continue since the table is reaching 4. So we say plus u 0.5, u minus 1 minus 0.5, u minus 2 minus 1.5, u minus 3 minus 2.5, change to the power of 4. Here is change to the power of 3. Change to the power of 4 is 0.0023. And then let's divide it by 24. So what we're going to be having is 1.0000 plus 0.1107 minus 0.006125, right? Plus 0.000681 minus 0.000090. So what do we have as a final answer? Our answer to this is 1.1052. So that is how NFI, Newton forward interpolation formula, is used. It is used to find the beginning of a table or values near the beginning of a table. Now, if you punch a calculator, you're going to have the same answer, 1.1052. Remember, they said y is equal to e to the power of 2x. That it means that if I put y is equal to e to the power of 2 into bracket 0.05, I'm going to have 1.1052. If you test it out, you're going to have 1.10 or something very, very close to this. So that is why, or that is how we use what we call the Newton forward interpolation formula. The Newton forward interpolation formula. Very easy to do, very straightforward, right? Good. Now, in our next class, we will be talking about the Newton backward interpolation formula. The Newton backward interpolation formula. All right.